I am Dr. N. Satyashila, Assistant Professor, Department of ECE, Rohini College of Engineering and Technology. The course code is 24EC304. Course name is Electronic Devices for Industrial Applications. Unit 5, Interface Electronics and Smart Industrial Applications. The lecture topic we are going to discuss today is Introduction to Temperature Sensors and Control Units. On completion, the students will able to understand about temperature sensors and control units and how the temperature sensors are used in different control circuits. Introduction to temperature sensors and control units. Temperature sensors measure heat to provide an electrical signal, often used in control circuits to regulate devices by comparing the measured temperature to a set point and activating an actuator like a fan. Common sensors include thermocouplers, which generate voltage, RTDs, which changes resistance, and thermistors, which have temperature dependent resistance. Control circuits use these sensors with components like microcontrollers, that is Arduino, or analog circuits to process the signal and send commands to an output, forming a feedback loop for applications like temperature regulation in electronics or appliances. Temperature sensor. A temperature sensor is a device that measures the degree of hotness or coolness of an object and converts this measurement into an unstable electrical signal. They are essential for monitoring temperature in various systems from household appliances to industrial processes and for providing the necessary feedback for control systems. Principle. Most sensors work on the principle that a material's property like voltage or resistance change predictably with temperature. Types of temperature sensors. There are several types of temperature sensors, each with different principles of operation. Thermistor. These are resistors whose resistance changes significantly with temperature. NTC thermistor. Resistance decreases as temperature increases. PTC thermistor. Resistance increases as temperature increases. Resistance temperature detector, that is RTDs. These use the principle that the electrical resistance of the material like platinum changes linearly with temperature. They are known for high accuracy and stability. Thermocouplers. Made of two dissimilar metals joined at one end, they generate a voltage proportional to the temperature difference. Silicon temperature sensor. Semiconductor based sensors that leverage the temperature dependent property of silicon to produce a voltage output often linearly related to temperature. Basic control circuit component. A temperature control circuit typically consists of sensor to measure the temperature, that is a thermistor. Controller, the logic unit, that is microprocessor or analog circuit that compares the sensor input to a desired set point, that is the limit we have set. Actuator, the device that performs the action based on the controller's command, such as a relay that switches a fan or heater on or off. Power supply, to provide power to the circuit components. A simple control circuit working example with a thermistor is given. Sensing. A thermistor is placed in a circuit often as part of a voltage divider and its resistance changes with the temperature it senses. Conversion. This change in resistance is converted into an corresponding change in voltage. comparison, the controller, that is the microcontroller or an analog comparator, reads this voltage. The action is that if the temperature is too high, the controller activates the actuator, that is closes a relay to turn on a fan to cool the system down and vice versa. This is a simple temperature